In this video, we're going to have a look at the logic behind Chapter 12B Question 1. So in this question, it's asking you to state the sine and the cosine values for these particular angles put in here. Now, the simplest solution is to just reach for the calculator and stick in these values and then see what you get and write that down. But that's not really going to explain why the values are the way they are. And the best way to look at that is through the unit circle. So consider the unit circle as being, or starting off with a string of length 1, and we're going to pin the string to the origin 0, 0, and then fan it or sweep it around the full range of 0 and 2 pi radians. So notice the shape that this is tracing out as it sweeps around the full domain. So 0 pi or 0 radians to pi radians. So you probably can see that it sweeps or it traces a circle. Now the second component is consider the location, so the x and y coordinates, as this sweeps around the circle. So in the first quadrant here, it's positive values. For the second quadrant, notice that the x coordinate goes negative. For the third, notice both the x and the y are negative. And for the fourth, notice that the x is positive and the y is negative. And back into the first, we're positive again. So what we can see is this dot represents the location on the unit circle. Now we can further describe that by notice the angle itself. For quadrant 1, this angle in the triangle here, it's like an interior angle. But then for quadrant 2, the angle that we're drawing becomes the exterior angle. So just notice the triangle as it sweeps around the unit circle. So based on this property, what it's asking us is, for these values here, notice that they're outside of the first domain or the first quadrant of the unit circle. So what we're going to expect for, say, let's not use these examples, we'll go down. Say we'll use an angle of, let's go 30 degrees. So this one I know it's 30 degrees because I'd done it earlier, but let's say this one inside it's 30 degrees. The location of the dot here, we can explain it by, explain the position of the dot by using these sides here and here. So what you find is that this green side here, it represents the opposite side, and we can say that that's the opposite. We can go sine theta equals the opposite over the hypotenuse, and notice that the length of this, because it's a unit circle, the hypotenuse is equal to 1. So this becomes sine, and substituting in 30 degrees, it becomes 0 over 1, or the opposite over simply 1. So what we find is this value here is represented by sine theta, and this angle in here, or this length in here, it's represented, or it's the x coordinate, so it's represented by this purple line across here. And because this is the adjacent, we can do a shortcut and simply say that it is cosine theta equals the adjacent over the hypotenuse. Hypotenuse is 1, remember. And then substituting in 30 degrees, the adjacent side is simply that. So this first coordinate is simply cosine. So what this tells us is the position of this dot here, no matter what its location is around on the circle, it can be explained by the cosine followed by the sine function. So going back up, when we're looking at to determine the values of sine and cosine, what this is telling us is it wants you to draw diagram of the unit circle, It's a terrible circle, but it will have to do. And it wants us to draw the location, or what that line would look like. So notice this one's at t equals 0. So it hasn't even got off the start mark. It's at 0 radians. So then the question is, what is sine of 0, not degrees, 0 radians? And what is cosine of 0 radians? And you can put that in your calculator and you'll be able to figure that one out. Now the next one is, let's pick a trickier one. Let's pick a trickier one, and we'll go, did that even worse, but it'll have to do. Let's go this one, 3 pi on 2. Well, if pi on 2 is up here, pi is over here, 3 pi on 2 is over here, and 0, 0, and 2 pi is there. What this is saying is, what triangle are we sweeping, or what triangle will we have if we sweep from 0 radians, past pi on 2, past pi, and up to here? So our line. So what positions will we have there in terms of sine of 3 pi over 2 and cosine of 3 pi over 2? So you put this in your calculator, it's going to tell you the values, but think about it. Why are the values the way they are? So what is this coordinate here? What is it? So notice it's 270 degrees, or 3 pi on 2. What will the coordinate be? Why will it be that way? So that's pretty much the gist of what we're doing in question 1 of chapter 12b. Thinking about or visualizing the behavior of this angle as it goes around or sweeps around the unit circle.